I have here a loop of wire, and over here I have a nearly identical loop of wire. I'm going to send an AC voltage, and therefore an AC current, through this loop of wire, and it's going to create a magnetic field and a magnetic flux through its center. We of course remember Faraday's law. One way to read this is if you apply a voltage, it will create a changing magnetic flux. But you can read it backwards. A changing magnetic flux will induce a voltage. So, if I have one wire creating magnetic flux, I can have that flux go into this wire to create a voltage. And if I have them overlap completely, theoretically they should have the exact same flux, and therefore the exact same voltage. For clarity's sake, I'll refer to the first wire, the one we're applying a voltage to, as our primary, and the second wire, which is receiving the flux and generating its own voltage, as the secondary. On screen, the yellow trace is the voltage across the primary. I'll now have them cross over each other. And you see that as they get closer and closer to having the exact same flux, they get closer and closer to having the exact same voltage, despite not even touching each other. We can wirelessly transmit voltage from one place to another. This concept is the basis for transformers. Now, when you've got loops of wire, the overlapping turns stack their effects. If a magnetic flux goes through this first loop of wire, there's going to be a voltage between this point and this point, but that magnetic flux is still also going through this next loop of wire, so there's going to be an additional voltage from this point to this point. That means that if you have magnetic flux going through two separate bunches of wire, and the two wires have the same area, the voltage should be proportional to how many turns each wire has. If we apply this concept to our transformer, we can take an input AC voltage and turn it into an output AC voltage with a different amplitude. If you're creating a larger voltage, this is called a step-up transformer, and if you're creating a smaller voltage, it's called a step-down transformer. And I have such a device right here. This coil has about 40 times as many windings as this coil. So if we send a voltage in here, we should get about 40 times the voltage out. And we'll check that with our voltmeters here. This voltmeter will check our input voltage, and this meter will check our output voltage. At 5 volts input, we have about 204 volts output, which is about 40 times. Now let's see what happens if we reverse our transformer, so that the larger coil is the input, and the smaller coil is the output. Once again, this will be our input voltmeter, and this will be our output voltmeter. And to get 1 volt output, we need to have 59 volts input. So it's a much more effective step-up transformer than a step-down transformer.